Imagine for a moment the intricate workings of the human brain, a complex network, finely tuned and delicately balanced. Now visualize this miraculous structure under the grip of addiction. The changes are profound, affecting thoughts, behavior, and emotions. This is the story of how an addicted brain works. In a standard, healthy brain, dopamine, a neurotransmitter, plays a key role in the reward system. When we engage in activities that promote survival, like eating or social interactions, dopamine is released, providing a sense of pleasure and reinforcing those behaviors. This is our brain's way of teaching us to repeat beneficial actions. However, addictive substances or activities exploit this reward circuit, triggering immense surges of dopamine, far exceeding natural levels. When someone becomes addicted, their brain undergoes significant alterations. Initially, the flood of dopamine creates an intense euphoria, but as usage continues, the brain adapts by reducing dopamine receptor activity. This leads to the user needing increasingly larger amounts of the substance to achieve the same high, a phenomenon known as tolerance. As the brain increasingly depends on an external source for dopamine, its ability to experience pleasure from regular life activities diminishes. This is why addicted individuals often find previously enjoyable activities less rewarding. Moreover, addiction affects the brain's prefrontal cortex, which is responsible for decision-making, impulse control, and regulating emotions. Over time, this area becomes compromised, impairing the individual's ability to think critically or make sound judgments. This explains why those struggling with addiction often engage in behaviors they know to be harmful or detrimental, despite the ensuing negative consequences. Addiction also ingrains powerful memories and learned associations in the brain, making even seemingly innocuous triggers a potential risk for relapse. A simple cue, like a certain environment, people, or even emotions, can activate intense cravings, compelling the individual to seek the substance again. Research shows that genetics, environment, and developmental factors contribute to addiction's grip on the brain. While some people may have a genetic predisposition making them more susceptible to addiction, others might fall into it due to environmental stressors or early exposure. But here lies a beacon of hope. The brain's remarkable ability to change and adapt over time, known as neuroplasticity. While addiction can rewire the brain, recovery has the power to induce positive changes. With appropriate treatment, education, and support, the brain can gradually restore balanced dopamine levels, re-strengthen impaired decision-making regions, and relearn healthy coping mechanisms. In conclusion, understanding how an addicted brain works is pivotal in approaching addiction not just as a series of poor choices, but as a genuine medical condition requiring compassion and comprehensive treatment. Through this lens, we promote a more empathetic and scientifically grounded approach to supporting those on their journey to recovery. The road may be long and complex, but with the incredible adaptability of the human brain, recovery, and indeed a thriving life beyond addiction, is not just possible, it's achievable.